Hello and welcome to the Mastercam 2021 Lathe programming session. So in this session I am going to teach you that how we can use drilling toolpath using cant cycle, deep drilling cycle and chip break cycle. So let's start. So go to the turning tab and here you will get the drilling toolpath which we will use for drilling purpose. So here you can go to the gallery and here you can select the drill strategy which we have to use. So before that you can check that which diameter we can use here. So let's check the ID, go to the home tab and select here dynamic. Select on this face, so it will show you that what is the maximum diameter. Maximum diameter is 184. So let's see. So we will use a minimum 40 mm drill, and after that we will use ID boring tools for ID rough turning. So let's see how we can using drilling cycles. How you can use drilling cycles. So let's go to the turning tab and here I will select drill, and now I will select the drill diameter which I want to use. So here I will select maximum 40 mm dia drill. So this one is a 40 mm dia drill, so I will select this one, and here if you double click on that icon you will get the tool geometry. So you can edit this tool geometry from here. You can edit the folder also from here. So here we can define the tools, which number tools we have to use. Here you can give the fit rate, RPM, all the things you can define here. And here I will say home position user defined, select from here and here. Okay, done. And go to the simple drill cycle, and here you will get the option to add the depth. So here we can add the depth. So I will select depth. I will go maximum. I will use maximum depth from here to here. So we can use deep drill through this hole. We need to use long drills. The length is minus 450, right? So this length is very much greater. So we can't use this much length tool. So I will say divide by 2. So I will do. This one is also very much high, so I will say minus 100 for. Okay, I will say absolute, and here I will say x0 and z0. Here I will give the clearance value 5 mm, retraction 2 mm, and here we can give peg drilling, and I will say first peg 2 mm and then subsequent peg 2 mm. Peg clearance we can give also 2 mm or 1 mm, and retraction is fine, and here I will say okay. So let's see how it is looking. So it's looking like this. So I will change the depth now. I will say depth from there to here minus 249. So you can see we need to modify that holder also because the tool length is very much high. So I will go to the toolpath parameter, and here I will change the holder length. So what is the length from here to here? I will say 250. So automatically our tool will it's showing some error. So we need to modify this tool length. It's 240, right? So I will say 260. Let's see. Yeah, it's fantastic. Okay, horizontal. So we need to do some other changes in drilling tool paths. You need to change the other options to regenerate the tool path. So you can see not looking good. Let's play it. we can activate the holder from here. So this is the peg drilling using 2 mm of depth of cut. Okay, fantastic. So now I'm going to show you the boring toolpath, ID boring toolpath. So what I will do, I will select these all drawings from here, and I will go to the height tab, and here I will create a geometry from here to here, because I don't want to go from here to here. So simply I can do that, and here I will use modify length, shorten 1 mm, 2 mm, and let's see, yeah, this one is good. And here I will divide it because I don't want to do all the area machining using this boring tool. Okay, so I will close this undercut groove also. So I will create a line, and here I will select that. So we can use other toolpaths for that grooving. Fantastic. I will select all the wireframe and I will say this width. Good. So next I will show you that how we can use ID boring toolpath. So simply I will select here rocking, and I will select the start point. So I think it's showing some error from this point to this point. Oh, okay. So there is some problem. You can see, yeah, right. We need to unselect that, and I will go to the rough turning. Okay, so it's looking good from here to here. Okay, so next I will use the tool ID boring tool. So you can see there is multiple boring tools there. So I will use 32 dia. 32 dia is also fine. So I will use these two, and now I will check the parameters. This is CCMT 1204.8 insert, that's fine. Boring bar, and what is the length? This is 350, fantastic. And here I will use the tool number, that will be 8 number, and here I will give the feed rate 0.1, RPM 1200, okay. User defined, fantastic. And here I will show you the can drop parameter. So simply I will click on that, and here I will give the clearance value, that will be 1 mm. Clearance in Z, that will be also 1 mm. Depth of cut we can give here 0.8, exit length 0.2, stuck to leave in Z 0.1, stuck to leave in X 0.2. And here we can give the lead in out. Lead in out we can give 0.5, lead in 0.5, lead out. Okay, and here roll cutter around corners none, and I will say okay. So let's see. So we have used 32 die, right? So this tool is colliding with this material because we have already extended this curve. So we have used 40 and this one is 32, and we have given also enter exit. That's why it is showing errors, but I will say okay, let's make it, and then we will modify it. So I will modify this length, I will say shorten 0.8, good. And I will not use this lead in out, and I will regenerate it again. Let's see how this is looking. Yeah, now it's looking fantastic. As you can see, this one is looking good, perfect. Now it's removing all the materials properly, and we have already given stock for finishing. So as you can see, these are the stock which we have to finish using finish strategy. Okay, so I will backplot it. Okay, so we have done this ID roughing toolpath. So next I will show you the ID finishing toolpath. So let's close this backplot, and here we'll go to the turning, and here I will say finish. So now I will use the same tool, and here you can copy this toolpath, you can copy this tool, and you can use point for insert also. And here I will use station number, same offset number, same feed rate 0.1, 1200 RPM. So now I will go to the can finish parameter, and here you can see we have to select this parameter carefully, because first one is OD turning, first one is facing, second one is OD turning, and this one is ID turning canned cycle. So we have to follow this scan operation to the finish operations. So we can select this one. So this toolpath, this finishing cycle will follow the old ID turning, ID rough turning parameter and geometry. So we will select this one, and I will say OK. As you can see, very easily we have created the ID finishing toolpath, and I will backplot it. Let's see how it is working. So as you can see, we forgot to give the entry, exit, and home position. So I will go to the user define, and I will say select, and very easily I will select entry from here. Okay, and I will say regenerate, and I will backplot it. Fantastic. Still it's going here. Okay, we'll check it. So this finishing toolpath is looking perfect now. Okay, got it. So that is entry exit value. So that's not an issue actually. Fantastic. So I think let's see how it is working. So I will backplot. I will verify it. I will select here verify, and we will verify with the actual stock, and let's see how it is looking like. So I will backplot, I will verify it from here, play, and I will say verify with color. These are all the extra toolpaths which we have created for example purpose. This is growing, audio growing, fantastic. Let's make it fast. So now I will show you ID turning uh, using section view. So I will select here, click from top. So easily it will be visible that how your tool is working in ID area. So you can see very fast. Okay, so you can see it's looking good. So first was drilling toolpath, second was ID rock toolpath, and the last one was ID finishing toolpath. So very easily we have done this, and this is very fast and very safe. Okay, so I will close it, and now I will show you the ID grooving toolpath. So I will hide it, and I will go to the wireframe mode. I will unselect it, and now I will show you that how we can create toolpath for this ID grooving area. So let's make that. So simply I will go to the grooving cycles, and here I will say chaining option, chaining method from here to here, and I will say okay. So now let's check it. So now I want to use these two, 12 or 15 you can use that. Width I will use 6 mm width of the insert, and I will use the tool number now, 8 number, 8 number, 8 number, speed 0.1, RPM this fine, spinner speed 1200, RPM for finishing 1500, fantastic. I will use the RPM, and I will use the user defined home position, select from here, okay, and now I will go to the groove set parameter, and here I will say ID, and I will go to the groove rough parameter, and here I will say rough bidirectional from center, stock amount, start 0.4, 0.5 above from this face, start to live in X 0.2, stop to live in say 0.1, and I will say step 50% of the tool diameter, and I will say groove walls steps, that's fine because there is no 3D wall. So if there will be any 3D wall, you can say smooth, and here you can give the peg groove, multiple plans, and depth of cut. Normally we use depth of cut, so depth of cut I can give from here. I will say 0.5 mm depth of cut, and now I will go to the groove finish parameter, and here I can say number of finish passes 1, and here you can give the overlapping between passes 0.05. Leading out we can use the normal, and I will say okay. So let's see how it is looking. So it's looking good. So let's play it, backload it. So the tool is moving very perfectly, and it's very safe and it's very fast to make that tool path. And if there will be any if there will be multiple grooves, multiple 3D grooves, so you can use that grooving options using multiple chains. So easily we have done this. Okay, so in this session we have done ID roughing, ID grooving, ID drilling, so now I will select unhide the model. This is the model. This is the model which we are using for programming purpose. So you can see these are the milling areas which we can done. We can create programs using terminal option. So and this is also possible on BMC3, BMC4 axis machines to remove these materials.